another recording? Oh, yeah. Okay. Let's do, I want to make sure you have some time to continue to practice this. So let's go and look at 4 and 5. This will be scanned in later if you need to go back to any of the first 3. Now 4 is pretty much the same as what we've been doing. Okay, so I have this shape, it's 4-sided shape. Now notice that here it's just the area. So we're gonna just be practicing area here. We don't have to do perimeter. It's nice when we don't have to do perimeter because then I don't need to do the Pythagorean theorem. I don't need to know what this length is, okay, to find the area. I'm going to draw in my right triangles. And I'll do the same here. I'm kind of assuming they're going to be the same on both sides. It's always a good idea to check, especially if it's an odd shape like you'll see today. We're going to have some odd shapes. And I'm just kind of color coding that I have the same there. So I've boxed in this kind of tilted quadrilateral. I've created this rectangle around the outside. The red triangles are 1, 2, 3, 4 for one leg, and 2, 4, 6, 8, 9 for the other. Someone else agree with me? My eyes just always cross when I try to do this from this distance away. 2, 4, 6, 8, 9. I still need to count that last little strip there, that last little bit of it, 9. Okay, and this should be the same. 2, 4, 6, 8, 9, and 2, 4. This is also 4 by 9. So I have 2 of those red triangles, legs 4 and 9. Then I have the blue triangles, which are 2, 4, 6. My eyes are really going nuts. 8. Okay. And 2, 4, 6, 7.
Yeah.
Okay. And this should be the same. Okay. So to find the area, what we need to do is find this big box shapes area and then subtract out these extra triangles. So this large rectangle that I drew in, this length is 12 units, 8 and 4 together. And this length, 7 and 9 together, would be 16 units. So to find the area, I'm going to find, well, what's the area of something that's 12 by 16? Okay, what's this total area here? And then let's subtract out these chunks, those triangles. So subtract 2 triangles that are 7 by 8 and subtract out 2 of these triangles that are 4 and 9 for the legs, and that's going to leave me with that inside area, okay? And we didn't have to do the Pythagorean theorem only because it didn't ask for the perimeter. It's just area, so I only have to work with rectangles, triangles to get my overall area. So then area equals, I'm not up for mental math today. Let's see, 16 times 12, 192. Remember, this one is base times height. And for my triangles, we're going to go 1/2 base times height. So I'll have 2 times 1/2, 7 times 8. Subtract 2 times, 1/2, 4 times 9. Okay, then I have 2 triangles with this area. I have 2 triangles with this area. Now, the reason I like to write that out is anytime I'm doubling a triangle, just going to get rid of that 1/2. 2 times 1/2, it's just undoing each other, okay? So I really can just do 7 times 8 because I have 2 of them, okay? So that's going to give me 192, subtract 56, subtract, and I'll just have 4 times 9 here, 36. So 192, subtract 56, subtract 36, gives me an area of 100 units squared for this inner quadrilateral. Okay. And the next parallelogram, same thing, but watch what happens here. So I'm gonna go, okay, I gotta draw in my right triangle, and I'd have a right triangle here. Okay, going from the end points, right, of where those sides meet up. And so this is 1, 2, 3, 4, 5, 6 units here, and 1, 2, 3 units there, and 3 by 6 here. And then on the other side, connecting the endpoints, just drawing straight, horizontal, and vertical to get my right triangles. Wait a minute, this looks different from what's happened in the past. My eyes are freaking out. There we go. Okay. And so what you notice, let me count units here on these, or attempt to. 2, 4, 5. 2, 4, 6. 2, 4, 6, and 2 and 5. Okay. What happened is that this parallelogram, skinny little parallelogram, I drew in my right triangles and it didn't create a rectangle. So when that happens, we need to add more shapes. I need to complete an outer box around this figure. So I'm going to add, to create a box here, I need to add a rectangle here and a rectangle here. Now I've created a box. Okay, so it's not always just adding triangles. Sometimes we have to add in additional shapes, and this is 3 by 5, 3 by 5. Okay, so I ended up having to draw in 6 shapes to box this in. 6 usable shapes. I could have drawn in funky shapes, right, that are not right triangles or are not rectangles, but we wouldn't be able to find the area of non-right triangles. So we have to use those kind of straight horizontal verticals here. So I've created a box that's 9 units this way and 11 units this way. Okay, I'm just adding up the parts that I have there. And to find my area, I have a 9 by 11 box that I made. And I'm going to subtract, gotta subtract these guys out, blue triangles, which are 6 and 3. And I have to subtract out the 2 red triangles that I have, which are 5 and 6. And I have to subtract the 2 smaller rectangles I had to add in that are 3 and 5. I have to subtract all those pieces I drew in to get that interior area. And we have to remember that the formula for rectangle is different than triangle. So I don't want to just get going and 1/2 all of these. Okay, this will just be base times height, but this will be 1/2 base times height. This will be 1/2 base times height. And this will just be base times height because it's a rectangle, it's not a triangle. So I have to kind of just flip, flip, flip back and forth between those 2 formulas. Okay, rectangles and triangles. And anywhere that I have 2 times 1/2, those are just going to cancel out. And so now I'm going to go down through, I have 99, subtract 18, subtract 30, subtract 5 times 3 is 15, times 2, another 30. And use my calculator. Subtract 18, subtract 30 and 30. Gives me an area of 21 units squared. Okay. And like I said, you can kind of check it. I mean, this one's really small to check, but 21 units squared means even if I took like these half boxes and made whole boxes, I would have 21 whole boxes if I somehow rearrange those to create, like take these little halves and match them up. So you can kind of count and see if that's a reasonable number when you take, say, a quiz on this material. Okay, it shouldn't be like if it gave me area is like 370 units squared, Okay, well, clearly there's not 370 boxes in there. Okay, so just like check it to make sure it's reasonable. Okay, so moving on from homework stuff. Find your notes. We're going to look at notes number 3 today. You should have 1 and 2 done. And it's gonna get a little bit weirder. Little bit weirder. And let me just check. So for you guys, I have us doing quiz review today, quiz review tomorrow, and then with the plan, see how's that gonna work? Because you're gonna have to be able to print the quiz. Maybe I'm gonna make a note to myself to give you blank graphs so that if you can't print, because the plan is that you take the quiz from home Monday. This quiz 1 on this stuff, but I don't want to give you the quiz to take home, I don't think. I don't think I want to do that. I need to think about it for tomorrow. What I can do is maybe give you blank graphs at least so you have those. That way if you can't print from home, you'll have the graphs. Still, that's going to make it trickier. I got to think about that. All right. So notes number 3, trapezoids and regular polygons. Yeah. So here we have a trapezoid. Like I said, one benefit of this unit is, yeah, we may be a little behind on notes. We got to get caught up, but it's all the same. Okay, so we just did triangles and then we did parallelograms. Here's a trapezoid. Same strategy. So where am I going to start? Get in a box around it, right? It's not a square on the graph, it's tilted, so I got to make a box around it. And so what we're going to see here, like we did on the last one, I'm drawing my right triangles, which is always, you got to be drawing like straight down and straight out so that it's square on the graph, straight horizontal and vertical lines. There's lots here. I don't know if any are the same. I guess I'll figure that out after. I don't think that, these 2 might be. Let me see. 1 by 1, 2, 3, 4, 5. Okay. So you drew in your triangles. Did I create a box? No. No, I'm missing like this little cube in the corner, right? So I need to draw a square there. I need to include that. Now I've created a box. I've boxed it in. Let's figure out what our dimensions are. So this is 1 and 5. This one's also 1 and 5. This cube is 1 by 1. 1 by 2, 4, 6, yeah. And 1 by 2, 4, 6, 8. Okay, and notice like I have to count, this is part of that line. So even though it doesn't matter how much of a box it takes up, it's how much like your line is going from this unit to that unit. What's that distance? It's 8 units across. Okay. All right, so we need to find perimeter and area. If we need to find perimeter, we need to find all these slants. So I'm going to give you some time to start Pythagorean theorem each of those triangles, and I'll do the same up here. Okay, each one we need to Pythagorean theorem on and find this length. there. Yeah, so anytime that I have the same rad, I can add those together. So I have one here, one here. I have 2 square roots of 26 plus the square root of 37 plus the square root of 65 units. That's, goodness, that's an ugly looking answer, but that's what you want, okay? That's how it's gonna look if you have radicals. I can only combine things that are exactly the same. I can combine those 26s and everything else just stays as its own term. And notice I still have units at the end. Okay, there's my perimeter. To find my area, I box this shape in. What size is the box I created? An 8 by 6, exactly. I have 1 plus 6 plus 1. I have 8 total units here, and 1 and 5, 6 units there. It is an 8 by 6 rectangle that I've created. And I need to subtract all the extra, which means I need to subtract the 2, they're identical red triangles, and the blue triangle. Let me draw in dimensions as I go. So the reds were 1 by 5, this is 1 by 8, and I need to subtract the yellow triangle, which is 1 and 6, and lastly, my little 1 by 1 cube. Okay, anything that I drew in to complete that outer box needs to be taken out now to leave me with the interior area. Okay. And triangles 1/2 base times height, rectangles base times height. So base times height here gives me what total area for the outside full shape? Yep, 48. Subtract, and I like to write out my triangles. 1 times 5, subtract 1/2. 8 times 1, I'm totally not gonna have space, subtract 1/2, 6 times 1, subtract 1 times 1. This is not a triangle. Sometimes you just get in a habit, like a pattern. Okay, make sure you switch back to just base times height if it's a square or rectangle. And only one of these has 2 of the same, so don't get in the habit of always putting 2 in front. That's not part of the formula. 2 is just in front if I have 2 of the same. It's nice when we have 2 in front because we can just cancel that out. So it's just going to be 5. 1/2 8 times 1 is going to give me 1/2 6 times 1. And 1 times 1 is 1. Sometimes I just type this all in, but then sometimes you just press something wrong in the calculator. So other times too, I just add this up. So this is 9, 12, 13 total that I'm going to be subtracting out. So that's another way you can do it. I'm adding up the total that I'm going to be deducting from that big rectangle. And what does that give me? 35 units squared for the area of that trapezoid. Okay. And so then we get, we'll do 2 more shapes and then I'll let you have some time to work on this. Then we get this pentagon. And so go ahead and draw on what you think you need to complete that outer box. We don't have a formula to find the area of a pentagon, so we have to use what we know, rectangles and triangles. 2, 4, 5. Your quiz has larger grids like this, which I think are a lot easier to, they're easier on my eyes, like to look at. Now, compared to the one we just did, would you call this one a little easier? Yeah, a little easier. We have 4 triangles total, but we really only have 2 different dimension-wise. So we only have to do the Pythagorean theorem twice here to get our missing length. Now, when you do the perimeter, you don't forget you have to include this, which is just lying flat on the graph. So this length of the pentagon, we still need to include 1, 2, 3, 4 units there in the middle. That's part of that shape. So that's going to be part of my perimeter.
Yeah.
Then for these lengths, I got a Pythagorean theorem. So go for it. Pythagorean theorem, find your lengths. Okay, see how you did? I got square root of 29 here. Same here. Square root of 34. Same there. Okay. So then for the perimeter, I don't want to forget this, so I'm going to write it first. I have 4 units on the bottom. And then adding all of this up, how many square roots of 34 do I have? 2. So I'm just going to write that. I have 2 sides that are the square root of 34. So I've covered these 2 in here. And then I have 2 sides that are the square root of 29 units. That's my perimeter. My area, what box did I draw in? What's the size of that outer box? 10 by 7, yeah. 10 by 7, and I have 2 triangles that are 2 and 5 for the legs, and 2 triangles that are 3 and 5. And notice, like, when I do area, I don't need these rads at all. The only time we use the slant lengths, those radical lengths, is when we're doing perimeter. Okay, when I move to here, it's always using the legs of the triangle for the 2 measurements that I pull out, okay? So 10 times 7, just base times height gives me 70, and I'm gonna have 2 times 1/2, 2 times 5, 2, 1/2, 3 times 5. Anywhere I have 2 times 1/2 is just gone, 1. So I'm gonna have 70 minus 10 minus 15, or 70 subtract 25 all together, just combining that. And what's my area? 45 units squared. Okay. Never changes. Doesn't matter what the shape is, even if the shape is something we don't even have a name for. Kind of looks like an animal. Maybe it's got some legs and some ear. This is its ear, right? I don't know. It's a polygon. So in order to find, let's just do area. No, let's do both. Let's do both. Because actually perimeter is sometimes harder when you don't have all rads that you're looking at. So box it in. Box it in. How would we box it in? I'm gonna do triangle here, which is 3 and 5. triangle here. 2 and 2. What else do I need? Top is going to be I'm using all my colored pencils in here. A rectangle up here. Right there. Have a rectangle. That's 2 and 8, yeah. Have I boxed it in? No, because there's this right here, right? So, let me use a different color. There's a 2 by 2 cube down here. Okay, and also in the end, we'll want to subtract that out. Now, on a shape like this, could you do it another way on this particular shape? Not on all of them, but on that one, I think you could. And this is what I mean. Could I have also broken it down into a right triangle on the inside, right triangle on the inside, and then I'm left with rectangles? Do you see how on the inside it also can be broken down into shapes I can use? So sometimes I see students do that. That's okay, as long as you're breaking the inside into usable shapes, right triangles, boxes. So for this one, I could break the inside into right triangle boxes and then just add up all of them. And that would give me my area for the inside, instead of finding a larger area and subtracting. Okay, that is an option. So I know some students like to do that. But it's not going to work for every shape, like those tilted triangles and stuff. So that's why we just kind of stay consistent. So I have 2 by 2. Okay, so in terms of the perimeter, I know some of the perimeter. I know that's 2. This is 8. This is 2, 4, 5 units here. 3. Okay, so let me write this down what I have so far. I have 2 plus 8 plus 5 plus 3 along the bottom. Plus I have 2 going up, then 2 more, then 2 more, or 2, 4, 6 all together to get around that shape. And then 2 more. We just don't want to lose any of those lengths. Okay, that's a really like they're there. It's easy to count them up. We don't want to miss a piece. We have to hit every edge there. So boom, 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 boom. Those are all my line flat on the graph lengths. What do I have all together for just those lengths? What does that add up to?
26.
26, yep. So all the way around, and this isn't our full perimeter, but that's 26 plus, okay, we got to find these. Okay, that's the end of our perimeter. So let's see, Pythagorean theorem, 3 squared, 5 squared equals x squared. 9 plus 25, I think we just did this one, 34. Square root of 34. Plus the square root of 34. I'm adding it in as I go. Here, 2 squared plus 2 squared gives me 4 and 4, or 8. Can I simplify the square root of 8? Oops, sorry. What can go into it?
4.
It's 4 times 2, or this becomes 2 rad 2, that length there. Whew. Okay, so there's my perimeter. Adding all of my flat sides up, and then slant length, slant length. To find my area, let me go, I'm just gonna move so you can still see the picture over here. Find my area, what size is the box I've created? 10 by 7. And I need to subtract out blue triangle. I only have one of them. It's 2 by 2. The red triangle, that's 3 and 5. The green box, that's 2 by 2. And the yellow rectangle, that's 8 by 2. Okay, that's how I'm going to find, ooh, I don't want that to be a part of my graph, my area. So 70 minus 1/2, 2 times 2, minus 1/2, 3 times 5, minus 2 times 2, minus 8 times 2. Remembering that these would not have the 1/2, the boxes. 1/2, 2 times 2, 2. 1/2, 3 times 5, 7.5. 2 times 2, 4. 8 times 2, yep. So I could subtract those individually, or I could say, let's see, that's 20, 22, 29 and a half. Okay. And what does that give me? 40 and a half units squared. Phew. Okay. So that's the work for today, and now you don't have work time, but that's okay. We worked. Where's my homework? So on the homework for the first version of the quiz review, you'll notice you get a lot of funky shapes, right? Like those are not standard shapes in there. Okay, and pay attention to what it asks. Like these two, this one, sorry, it's just area. So you don't have to Pythagorean theorem anything there. Just find the area. And then the first page is a little more straightforward, but still funky shapes. Okay, so that's homework for tomorrow, so that you practice this on your own. Okay, you got to practice this stuff, and then we'll do more reviewing of this tomorrow. And like I said, I'll figure out how you'll do this quiz. Maybe I will just have to send it home with you tomorrow. That might be the best. I mean,
Probably fine.
is it really any, you know what I mean? Like at the end of the day, you're going to be at home, so